Alrighty. So we got some of the Easily Campus, 2 out of 3 or 4 that show up for the Easily Campus, so that's pretty good. Today we're going to cover
man.
4 point,
Just
saying
50%.
2 out of the 3 or 4. 2
That's
out
awesome.
of the 3 or 4. I know, but usually y'all are the only ones that show up anyway. And then 1 comes in late. So
You should start taking attendance right at the end of the year, and everybody will freak out.
yeah, right. That's going to happen. Attendance is stupid for college anyway.
This is true. It is.
But not at Tri-County Tech. But like I said, 20 years down the road, Tri-County Tech will catch up with the rest of the nation. All right, so today we're covering 4.3, and 4.3 is not very difficult. I'm not going to use most of these slides because you can't read them anyway because they got so much fancy talk in them. So we're going to use my document cam. A one-to-one function is basically a function that only has one x and one y. Pretty much, that's it. Now, and I'm not going to spend a lot of time going over these PowerPoints just for examples, but in case of any of your functions, it's easier to see this graph-wise. A one-to-one function is basically 1x and 1y. So if you have a function and it goes something like this, you know that is a one-to-one function because for each x, you have 1y. And for this x, you have 1y. There is no point on this line to where you have 1x and 2 y's. Well, it shouldn't be. I think I might have messed up and drew it. Hold on a second. There we go. All right. And how do you know that? You basically draw a horizontal line test. Horizontal line test will tell you if you have a one-to-one function. If it intersects one time, then it is a one-to-one. And that's all you need to know, one-to-one. Oops. If it crosses more than one time, then it is not a one-to-one function. And the reason we're getting into one-to-one functions is because of, I think that's the way you spell it, symmetry. Okay? So if you draw a line through this function, you only hit it one time. That's why I had to redraw this right here because that would have been twice. So there's one time. It only hits one time. Now, there are also another reason we're doing the symmetry or the one-to-one function is also for the inverse function. Now, yesterday I had to go over inverse functions with my trig class, and I'm also going over inverse functions with this class. So that means you're both, the trig students and you as 109 students, are going to see inverse functions next semester in what? Calculus. So it's very important that you remember how to do inverse functions and what inverse functions is all about. So, and that's why I'm not showing you the PowerPoint, because most of you, if you haven't had symmetry and one-to-one functions in a while, the PowerPoints are probably confusing. So, let's take a function. Let's do. Well, let me go to the slides for an example.
We got 3 out of 4 now.
All right. I told you he'd come in late. See? I watch
Always
patterns.
do.
Huh?
Said always
You're not
do.
late. The clock is early, right?
Exactly.
Okay.
At least he's faithful late.
Yeah, that's true.
You
All
can
right.
always count on him.
Yep.
Right.
Be late.
Predictable. All right. Examples, inverse functions. Here we go.
He's late to the other Polycom class too.
Not anymore.
Yeah, he's not allowed to
Well,
be
that's
anymore.
because he lost his mind.
No,
All
that
right,
teacher's
here's-
crazy.
She told me she was gonna drop me from the class with an F if I was late again.
The other Polycom teacher's crazy.
F
Are
of
you talking about the micro one? Yeah, dude. She fills in for our macro class when our macro teacher's out. She is. Ooh, she's
Oh
brutal.
man.
She grew up in the old Soviet Union, you know.
Yeah.
So she's pretty.
She's hardcore.
She's like Stalin, you know.
She's like Putin, huh? She's pretty.
Yeah.
She's pretty tough.
Putin.
I like to say Putin. I don't like the other word, so I say Putin. I don't like the other word. So.
The other. You mean his name? Is that the
Yeah.
other word you're talking about?
Yeah, I don't like the other word. I don't like the POOT.
excuse
I don't
me.
like that. So anyway, the whole point is, here's the function. Now, when you're finding the inverse function, the first thing you do is you write the function normally. Okay? That means get rid of the f of x. You're not trying to impress anybody, so change the f of x to what?
Why?
Y. Second thing you do, exchange, interchange, whatever you want to do. I'm going to do exchange, interchange. I think it's interchange. Interchange x and y. So that means I'm going to take x and put it over here, and I'm going to put y over here with the fifth. So that'd be x is equal to y to the fifth minus 1. And then do what? Solve for y. So go ahead and solve that equation for y. Well, I got to add 1. So add 1. So x plus 1 is equal to y to the fifth. And how do you undo a fifth exponent?
The root fifth.
Take the
Yeah.
fifth root, yes. You do it on one side, you do it on the other. Y is equal to the fifth root of x plus 1. And that is the inverse, and you can put a little negative 1 right here. That is the inverse of the original y function. This right here is the inverse of this. So think of it as, I guess if you like the Wolfman and the vampire type movies, okay, this is the person, this is a humanoid, and this is what they turn into. In other words, it's the whatever you want to call it, the alter ego, if you want to call it that. But it's basically the opposite direction and the opposite reaction behavior. Now, what does that mean? Well, take your handy-dandy calculators out. And when you take your handy-dandy calculators out, graph these two functions. And this is the best way to show you, because if I take you through the PowerPoints, you're going to be confused. So this is the best way to show you. X to the fifth minus 1. So x to the fifth. Oops, I didn't hit y is equal. Y is equal to x to the fifth minus 1. And I'm going to make the second one darker. And I'm going to do the fifth root, so that's going to be x plus 1, parentheses, x plus 1, close parentheses, to the what power?
Negative fifth.
No, 1/5.
1/5.
Fifth power.
Gotcha.
And graph. There's that function, and then the other function is going to be exactly symmetrical, but it's going to be the opposite reaction. Okay? It's just symmetrical. They're both symmetrical. And that's what you need to be able to see. Now, what happens is, and I'm going to, when dealing with one-to-ones, symmetry, and inverses, the domain is restricted by direction or instructor. Therefore, the what is affected also. If the domain is affected, what is also affected?
The range.
Good. Now the reason this is for instructional purposes. In other words, the domain is restricted not because mathematically, but for instruction. All right? It's easier to see the one-to-one function versus, well, let me just put it to you this way. If I graph the sine and the inverse sine and not restrict the domain and range, you wouldn't be able to see either one because they'd almost be on top of each other. Okay?
Can I see what you put in the calculator again?
What?
Can I see what you entered in the calculator again?
Oh, yeah. There it is. So sometimes you have to limit the domain so you can actually see the graph better than if it's all on top of each other. Because, like I say, if you put the arc sine and the arc cosine on top of each, the sine and the arc sine, or some of the functions, if you graph the inverse on top of it and there's no domain, it looks like you're weaving a basket, and you really can't see anything on the graph. So what they do is they restrict the domain and range basically for better understanding and better visibility. Now, of course, if you ask any math teacher, they're not going to say that, but that's basically why they do. This is why in this section you will see some restrictions to the domain and range. What do I mean? They may say graph and find the inverse of f of x is equal to x cubed from 0, or meant from -1 or -3 to 3. And they might do it that way because all they want you to see is to see if it's a one-to-one. Is it one-to-one? Does it have an inverse? And what does the graph look like? Okay? And if you limit the domain, it's easier for the student to see those three things. All right? So just be aware that the domain may be restricted in some of your answers, but all that means is they're just making the graph shorter so you can see it better. Okay? Capiche?
Capiche.
All right. So let's get back to the PowerPoint and get another example. And of course, they showed you that this is the function here. So let's see. So find the inverse of this function. I have no idea what it looks like, but it says find the inverse of f of x is equal to 4x minus 3 over 5. Oh, y'all just send my birthday present and my Veterans Day present. Just send it through intercampus mail, okay? You know,
Sounds
checks are easy. Checks are easy to put in an envelope, okay? Cash. Yeah, that's good. So, y is equal to 4x minus 3 over 5. What's the nickname for Marines? Y'all know?
Worse than the Army?
No. Well, actually,
Waste of time.
USMC stands for Undersexed Misguided Children. That's what it stands for. But some people say it's Underschooled Misguided Children. But I'll show you what the I can't pronounce it half the time, so that's why I'm going to show it to you. There it is. Tuppelhundens. There it is. Tuppelhundens. Devil dogs. Get it from the Germans. The Germans nicknamed the Marines. You have to read about it. It's real interesting. World War I. Tuppelhundens. Anyway, it's our birthday
Hounds
today.
from hell.
Yep, that's it. Because they didn't have anywhere in Belleau Woods. There was a battle in Belleau Woods, and it was like two platoons of Marines went up against a bunch of Germans, and they didn't have any cover. There wasn't any woods because they were in a clearing, and the Marines took their helmets, and back then their helmets looked like flying saucers. Y'all know the helmets they had back then? They were like this. They looked like little cowboy, like preachers used to wear, like that. They had those little hats that I guess they were made out of metal, but they took those hats, they took those covers, or their helmets, I guess they call them, and they bent the edges like that and started digging holes with them. And they dug trenches with those helmets. And the Germans, they couldn't find them because they were in those trenches. They dug so many of those trenches, they were like 3 foot deep. And they'd crawl around in those trenches, and the Germans didn't know where they were. And they dug so many trenches that they actually dug to their flanks. And they were able to distract them in the middle, and they were able to attack their flanks because they dug trenches with those helmets. So I thought that was interesting. Anyway, I'll shut up. All right, x is equal to 4y minus 3 over 5. Now what?
Now you multiply both sides by 5.
There you go. You get 5x is equal to 4y minus 3.
Add
5x
3.
plus 3 is equal to 4y, and divide by 4. And y inverse is equal to 5x plus 3 over 4. Now, of course, this is a x to the first function, so what kind of graph is it? Is it a linear or nonlinear?
Linear.
It's linear, so you're going to have two lines like going in opposite directions, or they're going to be going in the same direction, but they have the symmetry. But it's hard to see with a linear function. It's hard to see. Well, there it is on the next page. I'm sorry. Hold on a minute. Here it is. Well, there it is. But they do have an intersection point. And how would you find the intersection point? Somebody tell me. And you do this a lot in calculus too. How would you find the intersection point? Come on, you people that know algebra. I'm waiting.
Use a calculator.
No. Calculator's what the high schools taught you. Huh?
That's always the answer.
Yep. How do you find the intersection point?
Isn't
Well,
there
the
some
silence tells me that none of y'all have a clue.
There's a
Is that
formula
correct?
for it, right? Is there a formula
Set.
for it?
Equal to what? Each other. Write that down. Whenever you want to find the intersection point of two functions, you set them equal to each other. So 4x minus 3 over 5 is equal to 5x plus 3 over 4. All right, get to work. Find the intersection point. Oops, hold on. There we go.
So
Now,
set
this-
the inverse equal to the original function.
Yep.
Okay.
Now, for those of you that may be taking a standardized test in the future, you might want to put stars beside this because you will see this in calculus, you'll see it in trig, you'll see it in any kind of math. Okay? If you want to find the intersection point, you set the functions equal to each other. So I'm going to multiply by 20, which is the common what?
Multiple.
Denominator.
Common denominator, common multiple, that's good. So that'd be 4 times 4x minus 3 is equal to 5 times 5x plus 3. 16x minus 12 is equal to 25x plus 15. 16 is the smallest bucket, so I'm going to bring it across the river. Negative 12 is equal to 25 minus 16 is 9x plus 15. 15 comes across the river, be a negative 15. It looks like 3. X is equal to negative 3. Somebody check me.
Yes. Yes.
And now you can plug negative 3 in for x. 4 times negative 3 minus 3 over 5. And this is my back substitution. So negative 12 minus 3 over 5 is negative 3 again. So at negative 3 and negative 3, we should have an intersection point. So let's look back at our handy dandy graph. Negative 3 and negative 3. Look at there, it's a miracle. Now, with any function, when x to the first is the function, your line of symmetry is always going to be x. See the little dashed line going up through there? Hold on. See the dashed line? That dashed line is y equal to x. All right, you need to write that down because that's your line of symmetry. It's called a diagonal line of symmetry. And with x to the first functions, whenever you have a straight line, that's always going to be your line of symmetry. All right? Okay, let's look at this one. A business property is purchased with a promise to pay off a $60,000 loan plus $16,500 in interest on this loan by making 60 monthly payments of $1,275. The amount of money remaining to be paid on the loan plus interest is given by this function. Write that function down. Where x is the number of monthly payments remaining. Find the inverse of this function. Use the inverse to determine how many monthly payments remain if $35,700 remains to be paid. All right, so find the inverse of that function. F of x is equal to 76,500 minus 1275x. I'm going to rewrite that because, I'm going to rewrite it because I don't like the way that's written. I'm going to rewrite it like we've been writing algebraic sentences since y'all been in 6th, 7th grade. F of x is equal to negative 1275x plus 76,500. Y is equal to negative 1275x plus 76,500. X is equal to negative 1275 y plus 76,500. X minus 76,500 is equal to negative 1275 y. Divide by negative 1275. Divide by negative 1275. And y to the negative 1 is equal to, and you could divide this by negative 1 up here and get negative x.
Yeah, 76,500 divided by 1275 is 60, by the way.
Okay. But you don't want to do that because then you'll have x over 1275. So you want to leave it alone. X minus, that'd be x plus 76,500 divided by 1275. And what I did is I multiplied through each term by negative 1. Now negative 1 over negative 1 is what? Positive 1, so I'm not changing anything. Okay? So there is your function. And like you said, you could rewrite that as negative 1 over 1275x plus what? 60?
60, yeah.
Equals y to the negative 1. You could write it like that. And you could graph those two and find out where they intersect, but they don't really care about that. All they want you to find is what something is equal to when it's equal to something. What does it say? Use the revert inverse to determine how many monthly payments remain if the total were X up here. What is payments? By making monthly payments of $12.75, X is the payments. So that means if X is the payments, what is Y? 35,700. So 35,700 is equal to, did easily just go out? Y'all didn't let me know it easily went out. Next time Easily goes out, somebody let me know, please. Easily, you back with us? How long you been out?
A while.
Well, Pendleton stabbed you in the back. They didn't even say anything.
Figures.
Yeah, they don't care about
We didn't
y'all.
know. They don't show us.
We can only see the one box.
Y'all don't see Easily?
No,
No.
we see you and ourselves.
That's
I
how
don't
all
need
it
them.
is to us.
Okay, well, at least we got everybody. Okay, I don't know why. Maybe one day Tri-County Tech will get with the program 25 years from now.
We stopped when you were finding the intersection point.
Oh my gosh. Okay, well, we're doing this problem right now. All right, read
Sweet.
this problem.
I didn't want to know how to do that anyway.
Okay, well, let me go back. Hold on. Let me find it. Here we go. Let me
But
go
this is
back.
direly important. You're going to do this in calculus and...
Yeah, I know. I'm sorry. I didn't even think. Hold on. There we go. All right. This is where I was with that problem. Is that what you're saying?
Yep.
Okay. Tell me where's the last I left off. Where did I leave off?
When you circled...
When you square it off, the bottom left.
Okay.
5x plus 3 over 4.
All right. And now you want to set them equal to each other. And here's where I set them equal to each other. Right there. And I multiplied by 20 on each side because 5
Sure.
times 4 is 20.
Okay.
And I solved it, and I got negative 3 for x. And then I took that negative 3, and I back substituted it into the original up here. I'll show it right there. So just go ahead and write that down, or solve it right quick. and then we'll take it up to the top where I back substituted.
What is that right under 4 times
16.
16x?
I distributed 4.
I just couldn't read the 16. That's my bad.
This is my fault. The Russians. This is a Russian pen.
Damn Russian. You know, I tell you what it is, Mr. Hubert. It's that other Polycom
It
professor.
is.
She's probably ex-KGB.
Yeah, that's probably what it is. Sabotaging my
Have you seen that
class.
episode of The Office?
Which one?
The
Yep.
KGB waits for no one.
All right, now back substitute the -3 into the original, and you get -3. So these two intersect at -3, and we went back to the graph, and that's where it intersects right here at -3 and -3. And I also told everybody that go back to the here. Write this down. Whenever you have x to the first as a function, the line of symmetry will always be y is equal to x. And that is this, oh shoot. Oops. That's this diagonal line. It's called a diagonal line of symmetry, which is the dashed line. Yes, sir. You got a question?
No.
You can click back for a second.
Yeah. Oh, you mean on the,
Yeah.
okay.
Excuse me.
So y'all didn't hear my story about the devil dogs, the Tufflehundens?
We heard that.
Oh, you heard that? Well, good. So if you know anybody that's in the Marine Corps, which is not many, you can tell them happy birthday today. Guess
Happy
where the Marine Corps was organized?
Where?
In a bar. Tuns
Hell
Tavern.
yeah.
Yep. Have to look it up. TUNS Tavern.
What state?
I think it's Pennsylvania. I think it's still there.
It's a historical landmark.
Yep. 200 and
It better be there.
1776. November 10th, 1776.
Oh, it is now. Oh, that's not
Okay, y'all caught up now?
Yes, sir.
yes.
All right,
Appreciate
now the question that we're doing now is this question
Oh,
Huh?
right there.
$10 for 10 tickets, and they draw a ticket, and you win the jackpot. It was $6,800.
What are y'all talking about?
There's this bar in Moville. It's like old retired Marines and stuff. I forget. It's called VFW.
Uh-huh.
It's like all the support Marines or whatever. And I tell you, I went there last night because they do like a jackpot thing.
Yeah.
Pay $10 for 10 tickets, and they draw a ticket. And if nobody wins, it goes on to the next week, and so on and so forth. But last night it was $6,800 and some change.
Y'all know what that's called, don't you?
They said what it's called, but no. I
It's
don't
called a
know.
lottery.
Oh yeah, I mean, pretty much. That's not the word they use, but yeah, I mean.
Well, that's what it's called. Anyway, go ahead. Write this down. And or just take a picture of it for time purposes if you can. But
Yeah,
anyway,
All right.
if you're going to copy down anything, just copy down the f of x is equal to 76,500 minus 1275x, because that's the function. And they want you to find the inverse, and then you plug in 35,700 for y. So that's what I'm doing right here. I found the inverse. Here's f of x is equal to 76.5. I turned it around. Then I took the f of x out, put y. and then I interchange the y and the x, and then I solve for y to get y inverse. And now I'm up here, I'm setting this equal to that. And we're going to solve for x, which is the payments. So negative x plus 76,500 over 1275.
What is 35,700 again? The payments you said?
I'm sorry. What?
What was 35,700?
Hold on. Let me go back.
I know, I
76,500. Oh, right here. 35,700. I'm sorry. That is, use the inverse to determine how many monthly payments remain if 35,700 remains to be paid.
Okay.
Okay?
Yeah, I'm good.
And they probably went ahead. Is this what we got? 76? Yeah. 76 minus x over 1275. And then they're plugging it in. Plug in 35,700. Okay, they want you to plug it in, not solve. Okay. I read the question wrong. F of negative 1 of 35,700 is equal to negative 35,700 plus 76,500 over 1275, and work that out. You're going to get 32 payments remain. So you can tell that the inverse in business will give you how many payments you have left if you're given a certain type of question about payments. Velocity of blood. Okay, that's interesting. Because of friction from walls of artery, blah, 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 by the function, the non-negative meaning positive velocity, because velocity cannot be negative, in centimeters per second of a blood corpuscle in an artery can be modeled by the function V is equal to K times R squared minus X squared, where K is above 0 and X is between 0 and R, so X and K are positive. Where A is the radius of the artery and K is the constant that is determined by the pressure, the viscosity of the blood, and the length of the artery. So what they're going to ask you to do is they're going to ask you in a second to find the inverse of that. We find the inverse of the function. So go ahead and plug in those numbers because they're giving you those numbers. Wait a minute, where is it? There it is. Okay, so find the inverse of this function. So V of x, wake up. V of x, one person at the Anderson campus. V of x is equal to 2 times 0.01 minus x squared. And I'm going to f, or y, is equal to 2 times 0.01 minus x squared. X is equal to 2 times 0.01 minus y squared. I'm going to distribute that 2 because I don't like to. We can divide by 2 on both sides, and that's fine. But I'm going to distribute that 2.
Will you switch to your document cam?
Oh, I'm sorry.
You suck.
Thank you. I know. Just write me off as being a loser. All right, now this is some rough math here. 2 pennies is equal to what? 2 cents. Minus, I've actually had students put this in a calculator. That shows you how dumb students are. 2 pennies is 2 cents. Minus 2y squared. Okay, now I'm going to subtract this 0.02. So x minus 0.02 is equal to negative 2y squared. Divide by negative 2. Divide by negative 2. Y squared is equal to x minus 0.02 over negative 2. And take the square root of both. Take the square root of both. And y inverse is equal to the square root of x minus 0.02 divided by negative 2. They'll probably want to factor out that negative 2. They probably do in the next. There's that negative 0.02 right there. Why'd they get negative? Okay, now I don't understand how they got a negative right here.
You're idiots.
Anybody want
Did the Russians make this?
to? I don't understand how they did that. Somebody want to help me out? Because
I think it's a mistake because the next one down is positive.
yeah, they don't. Okay.
Huber gets humor in math.
Yeah, I mean, no, I get. They have a negative right here, and then they have a positive. So let me look at this a minute because I don't understand. Everybody look right here. I don't understand how you multiply 2 times 0.01 and get negative. So I'm looking
Maybe you
very
need to put it in a
carefully at that.
calculator.
Yeah. Yeah, that'll fix it. That's what some people think. Okay, so let's just assume that's a mistake. Here, they brought the x over, and they took this over. Okay, that's good. Maybe that's what I should have done because my negative. Oh, wait a minute. Okay. We can take that 2, the negative 2, that negative, and divide, and we could get y inverse is equal to be negative x plus 0.02 divided by 2. Is that what they got? Yeah. That's what they got, which is the same thing as what they've got right here. 0.02 minus x, 0.02 minus x divided by 2. So they didn't do anything. Now that's an error right here. This is an error. That's a typo right here. That should not be negative. So just to kind of ignore that. All right, but this is the same as this. So they really didn't. Right here, that's what I did. I divided this. I've multiplied through by -1 over -1, or I divided this and this by -1, and you get this. So it doesn't. You'll get some. Most of you have either this or this. It doesn't matter. They're the same thing. Okay. Whether you have a -2 on the bottom or a +2 on the bottom, as long as these are coinciding, it doesn't matter. Okay, and I don't know what they're doing next, but okay, it says the inverse function gives us the distance from the center of the artery as a function of the velocity of the corpuscle, and that's it. That's all you got to do. Okay? So, in this is what chapter? 4.3? In 4.3, we're talking about one-to-one, meaning horizontal line test. We're talking about symmetry. We're talking about the inverse function. Now, with the inverse function, make sure you can do it algebraically, because that's what I'm going to test you on. Okay, so put a star beside algebraically. Probably talking about 20 to 30% of your test. So if you got 10 questions, there'll be 2 or 3 from this section right here, algebraically, just like the problems we did today. So make sure you can go from a regular function to a inverse function. My boss is fixing to come in. She may not come in, but if she does, don't act like hoodlums, because we got a meeting after this class. So make sure you can go from a f of x function to a inverse function without any trouble. And make sure that if you do have an inverse function, make sure you can plug and chug accordingly to what the question's asking. And that was that question about the interest or the number of payments and all that.
Plug dash in dash chug.
Yeah, plug and chug. Yeah. Y'all don't see that? Don't tell me you've never heard of that before.
No, I have. I just thought it was funny how you wrote it.
Before your class, I haven't.
Well, that's because I've lost my damn mind.
That's right.
This polycom makes you lose your damn mind.
I was like, I guess it's something to do with this polycom, because
yeah, it is.
I wouldn't say that about you.
It's this silver disc right here submitting radioactive waves, and that's why we've lost our damn mind.
You're nowhere near them. Close to her.
Listen, I've been in meetings, I know. But anyway, all right. So, everybody good with finding the inverse function?
So did you say you were going to open up the homework, or?
It should be open.
Oh, okay. I haven't looked yet.
Is our test next week?
When do we have a test? Whenever I go over what?
Whenever you tell us to.
Exactly.
Well, I remember you saying the other
Tell
day
me,
that
y'all,
it's like,
is it just like water off a duck's
I mean, we
back,
just got like
well, I just
2.5 weeks of class.
I didn't know because
left,
you said
so.
this test was broken up into 2 parts. I didn't know if it'd be
Y'all
like that.
suck. Y'all just suck.
Hubert,
That's all there
I'm
is
going to
to it.
blindly follow you wherever you lead me. So.
That was good.
Isn't that what the core teaches you to do, Mr. Hubert?
Yeah, follow blindly and dig holes. Listen, y'all have a good weekend. Be careful, okay?
Hey, Mr. Hubert, can I talk to you about some?
Yeah, let's look that up right quick. All right, y'all be good and be careful. All right. Let me turn the recorder off right quick.
All right.